system is going to hold processors that you add to it, and it's delegated through the world. And then you need to execute those processors. So effectively, you get we have some archetype signature, like we said, is the exact component set combined with these data frames, and then it runs in priority order, running those processors, and then appends that data back. This becomes a lot simpler once you move to asynchronous, but the whole point here is that we're decoupling all of the responsibilities. The way that this ends up working is your world is running the simulation. The first thing that happens is the store reads from a table, and then your querier retrieves, takes that data, and passes it to the system, and then the system processes those processors, and then the updater sends that data back to the store where it finally appends the data with using the semantics of the archetype. Now, the way that I'm using all of these technologies has made it so that this is a very custom solution. But on the scripting side, for anybody that wants to use this library, the whole point is that it's much simpler for them to write it. Not for humans, but for large language models. Particularly, the thing that I've been looking for isn't to make a tool for developers, but to make it so that a large language model has the right primitives to write great code. Code that I trust, that it can use, and I think my debugging session on my drive over here with Claude is probably proof of that. That being said, I will go ahead and run our simulation here. I did set. Same thing with the asynchronous simulation was the same thing, but it's running all of the archetype tables in parallel. You have to run that over that loop, and then the processors have to be run in order, given the simple priority system that I have. The next extension that I'm planning on adding is graph support, where you can describe DAGs, and then you can run those processors in an arbitrary DAG. I'll be planning on using NetworkX for that, which has not only a Pandas backend, but a CUDA CUDF backend as well. So all of this can run on Apache Arrow and super fast on GPUs.
iGraph is better sometimes. Like way fast. iGraph is really fast.
Really? Okay.
NetworkX sometimes lets you down.
Okay, well that's good to know. Okay, so same thing here. And Claude gave us all sorts of doc strings and print statements. I told them, hey, I've got an API Tinkerers demo in an hour. You better fix this for me. All right. Okay. So what we're going to see. I'm not a brain police. Okay. So we're only running something like maybe 10 steps. Yeah, 10 steps. But I had to print the updates that I'm appending to each archetype table, which I only have one of in this toy example. And this is what it looks like. I've got these world IDs, and then a run ID, and then an entity ID, which means I should be able to run multiple worlds in parallel, in addition to multiple archetype tables at the same time. And I use semaphores from the async IO library in order to manage that concurrency. So a semaphore, for folks who don't know, is essentially a queue of allotted concurrency, and you can take that and run your process and then give it back to that queue, and then that's what you end up getting. And someone who knows way more about semaphores is probably gonna correct me on that, but we've got data frames. It's updating. We can see that for this entity, 1 on this run, and these are ULID identifiers, not the UUID ones. UIDs are just random. ULIDs have timestamps in them. Then we've got our velocity, which is staying the same, and we can see our position is updating. Thank you, demo guys. Now, one thing that I was not able to get Claude to swing for the fences for, but I do want to show you, is an actual multi-agent simulation, right? So I have a simple system and an asynchronous system. Asynchronous systems are way better for agents to be able to communicate with each other. And integrating that with a graph library will help us define those communication networks. So I think it's just worth it to walk through what it wanted us to do. And yeah, I'm doing this, move the Python path because I don't know what I'm doing sometimes. We've got our traditional positioning and velocity components. It describes an agent. This isn't how I would describe an agent. But from there, we've got an agent state, we've got our processor, and this is just doing our position updating. It wants to do a sleep, so that for some reason. And then we've got decision patterns, apparently. So this is generated code. I didn't write this, haven't reviewed it either. But leaning into who's the vibe code guy? Not the vibe code guy, but Rick Rubin on his recent paper on vibe coding. If you let the AI do the thing, then maybe it'll surprise you and you'll get something unique and emergent. That's really my goal with this entire project, is as humans, we're too stupid to write really good code in like half a second. And it's just unreasonable for us to believe that as these models improve, that we'll be able to keep up. And I think if I've shown you anything today, the ability to scale an agent simulation that's decoupled like this to thousands or millions of entities running large language models in parallel should tell us all that I think the paradigms for how we're working are changing. And particularly my goal for Arhectype is to reveal emergent intelligence patterns. And a lot of this, like what we just saw before us, is data engineering. Plumbing the prompting, how do the agents get the context that they need? And so my plan for some of my next extensions, besides graphs, besides these multi-agent topologies, is to give these agents the ability to query those tables themselves. And that's a big deal, because it's essentially giving each of these agents the ability to go and fetch their own context. And I think that's what you see when Claude Code goes and finds the different pieces of the code base that it thinks is necessary. It's indexed that right. Imagine not just the 12 or 24 Claude codes that people are running on the computers right now on Twitter, but millions. It's a very different world, and I think to me, this is the crazy fever dream that I had when I first started seeing working with ChatGPT in 2023. And if I can do it, especially working as a product manager, not a data engineer at Lucid Motors, and I'm able to develop something like this, essentially going from nothing working to
blue screen.
from nothing working for about 5 months to getting something working 2 weeks ago to having 2 extensions now and having debugged it on my car on the way here. I think each of us should go out there and experiment, and I think there's not only going to be new players, but completely new ways of working and interacting with these LLMs that we haven't seen. So that's my presentation.